Hello and welcome to the Plastic Recycling Podcast. We have Apurba Pradhan with us. Apurba, you have a degree in physics, a degree in optical engineering, an MBA from Berkeley, a very interesting intersection, and now being involved in recycling. Tell us a little bit about yourself.
Yeah, I'm in charge of products at EverestLabs. My job is really to help the company navigate the industry, navigate our customer challenges, and form the direction for our products in terms of roadmap and in terms of how we're meeting the customers' problems head on. And in that, I've been doing product roles for over a decade now. And, what this particular company is very, very interesting because it combines sort of the latest and greatest in AI technology and robotics technology with solving a very big problem that's necessary to solve, which is really enabling circularity and recycling, especially plastics recycling. So for me, it's a perfect fit with my interest and my background. Everest Labs has been in business since 2018, so it's a 5 or 6 year old company. But first few years of that were sort of heads down developing the AI technology that's enabled us to build these products. We really launched our first product in 2021, and we are finding success with recycling companies, in particular material recovery facilities that are facilities that collect and sort recyclables that get discarded, and then recycling companies like reclaimers and reprocessors who buy those materials and then they process them back into raw material to sell into various uses, one of them being packaging manufacturing. So we sell AI and robotics to those companies to help their operations take the next.
Apurba, let's zoom out. Let's talk about what are the challenges? What are the challenges that you see the plastic industry facing from the material recycling facilities that you're seeing, which is essentially where all of our trash goes, right? So talk to us about what you see. What are the challenges you see? And then we can dig a little bit deeper down that rabbit hole.
Yeah, I say, the recycling has a number of issues that need to be solved. From my point of view, the biggest one is really the lack of high quality recycled material going back into the supply chain. I think people are aware of things like low recycling rate of plastics, and people are aware of the fact that consumer behavior needs to change and so on. But people are generally not aware of the operational issues in the recycling value chain that lead to the shortage in high quality plastics. So if you work sort of backwards, you see brands that make products that use packaging. They cannot meet their circularity commitments. They all have sustainability, circularity sort of commitments. And they're falling short on those commitments because the packaging manufacturers who make packaging for them are not able to keep up with the demand for recycled packaging. If you go back in that value chain, the packaging manufacturers can't access enough recycled material from reclaimers and reprocessors at good quality and at low cost. You know that recycled plastics actually claim a premium over virgin plastics, even though virgin plastics are more versatile and probably make easier to use virgin plastics than recycled plastics. And yet packaging manufacturers still have to pay a premium for that. And they can't get long-term supply locked up. So, and you take a step back from that, the reclaimers can't produce enough of this plastics because they don't have enough feedstock coming in from collection facilities and recovery facilities. And so if you take a step back and say, okay, why can't the recovery facilities provide enough recycled plastic feedstock? It's because they're dealing with very manual operations. And there's several studies out there that show that different types of plastics between sorting and processing the losses are somewhere between 20 to 70% of what is collected don't get put back into the value chain. So there's all kinds of operational issues stemming from recovery facilities not being able to sort and provide that plastic back in the value chain, and then reclaimers not being able to access a wide enough supply. And so as a technology company that's developing AI and robotics, we try to solve some of those problems way up into the value chain by working with material recovery facilities and working with reclaimers and reprocessors.
Hmm. So essentially saying is we have enough trash. We can recycle if we do recycle all of it, we probably will be able to meet a big chunk of that circularity commitment. It's just material is lost in the value chain because the machinery that's there is not up to par. It cannot see that this is a recyclable product and this is not a recyclable product. Do I have that correct as a summary of what you're saying?
Yeah, more or less. I think that
Um,
the operations are very manual in these recycling facilities, and if you go
yeah.
visit one, you'll see what I mean. It's miles of conveyor belt moving a stream of material, a lot of which is non-recyclable, and all of it is mixed in together. And you
Mm,
use very industrial pieces of sorting equipment to separate metals and plastics and glass, and within metals and plastics, separate them into aluminum and then steel, and within plastics, separate them into PET and HDPE and polypropylene and all the different types of plastics that need to be separated is processed differently. And so you can't just
mhm,
process, all the plastics together. You need to do a good job of separating it. And you'll see that
mhm.
a lot of sorting equipment that's on these conveyor lines, you still
Yeah.
have manual sorters, people standing at the end of these lines, separating them by hand.
Cool. So tell us about how AI robotics can help to fix or improve that system and probably reduce costs dramatically, right? Because if your yield is much higher, you're using more automated processes versus manual processes, then that cost should dip considerably. And therefore, hopefully, recycled material at some point comes on par with virgin, hopefully less than virgin. Talk to us a little bit about what that flow looks like.
Yeah. I'll paint a picture for you, and then
Yeah.
we'll get into the costs and the
Mhm.
economic things.
Yeah.
But the setup is fairly straightforward. We use vision based AI, so we install cameras, basically like stereoscopic cameras, two cameras that are looking at different angles that can determine height of
Mm,
objects as well. So you're creating like a 3D video of the materials flow under in a recovery facility on a conveyor line. That video is then fed into an AI model. The AI model, we call our AI model a large vision model. We use computer vision techniques, deep learning techniques, as well as data synthesis, data generation, to be able to train those models using like large language model techniques. And so all of this combined creates an AI model that can then identify every object on that belt with very, very high accuracy. We've trained the model to recognize around 50 to 60 different categories of recyclables. So,
mhm,
it's not just detecting something like PET, but it's detecting PET water bottle clear, PET, water bottle colored, the water bottle shrink wrap, for example, or, just determining between food grade and non-food grade plastics,
mm,
determining between different types of clamp. So it makes various types of determination on that object. It will record the dimensions of that object. It will convert those dimensions into mass or weight. It will calculate what the material type is, what the packaging type is. It can go as far as calculating the economic value of that particular object is, and even can recognize brands on particular types of packaging classes. So all of this information is extracted by the AI model. Our AI models are somewhere between 90 to 97% accurate in production. So with between the 90 plus percent accuracy, we can tell exactly what that object is. Good. So you got a lot of information there already, right? So now you
mhm.
can say what's coming into that plant, or where,
Right.
depending on where you place these vision systems, these camera systems, you can tell how that material is flowing around in your plant. So the first thing you can do is just make an assessment of how materials are coming in and going out of a plant. So you can kind of determine plant's sort of overall efficiency, right? And you can determine it at the plant level, or you can determine it at individual process steps. And now just that is information that the recycling companies didn't have up until a few years ago. So, just with that information, they can do a lot of process optimization that they weren't able to do, right? And they can optimize for material type, they can optimize for value, they can optimize for landfill costs, all of these things because now you have that data. Um, and then the next thing you can do is, okay, well, now I have a lot of manual processes. How can I automate some of that? How can I remove some of these manual sorters who are picking these materials off a line, which are extremely difficult jobs, jobs that have very high turnover, jobs that are extremely hard to fill. How can I automate some of that? And so we have developed robotics that essentially fit into a form factor of a person sorter that installs on a side of a belt and basically picks at somewhere between 40 to 60 picks per minute these objects out of the conveyors. If you compare that to a person's performance over a shift, it's about 2 times better than what a person might pick with higher quality or higher accuracy. So now back to your statement about economics, we've developed the robotic system so that it actually costs less than labor rates are. So the payback is almost instantaneous. So that's one of the big reasons that we're getting traction with recycling companies is the economic value of the system is so great. Forget about the difficulty in hiring and difficulty in retaining people. Just the actual cost of these systems are much lower. And then it's also very flexible. So let's say that those robotics can be programmed one day to prioritize certain type of plastics, the next day to prioritize something else, or work in tandem with a person who's also on that line, or work in tandem with other robotics, or work in tandem with things like optical sorters and work in tandem with things like eddy current separators that are already there in these plants. So now you can be a lot more versatile, right? So let's say that, the commodity pricing for certain type of plastic is going up. You can prioritize these robotics to pick those materials for that time period. So now you got a lot more flexibility in terms of how you manage your material streams and how you manage your recovery process. So we give all of that flexibility to recycling companies to basically help their operations.
And does the robotics get fed data from those two initial cameras?
The robotics have their own camera. The robotics have, if you're installing a robotics on a line, it needs a vision system dedicated to that robot, or maybe
Mhm.
2 robots or 3 robots, because the vision system is directly informing the robotics what to do. Right.
So if the economics are almost instantaneous positive ROI, what challenges do you face in particular when you go to an MRF or a recycling facility and propose this particular system? What pushback do you see?
It's a good question. I think one is just familiarity. I think that's
Mm,
the biggest one because, recycling companies and operators of recycling companies, this might be the first time they're encountering an AI system and a robotics system. So they don't know what they're going to get. Right. And so what we do to overcome that hurdle is do performance guarantees. We essentially provide a full service, what we call a robot as a service model, where the operator pays us one fee and we run the system on their behalf. Because if you go to a recycling facility and say, hey, I'll sell you an AI and a robot, they don't have an engineer on staff who would be able to run those systems, right? So they're like, well, I have to hire a person 3 times more expensive to now replace manual sorting. So that doesn't work. So we basically provide this as a service where we will work with the material recovery facility or the recycling company to get their priorities. We will work with their electricians and their people who do infrastructure work for them, like electrical and mechanical infrastructure. We'll work with them to install these systems. And that usually takes like a weekend, right? It's a couple hours worth of work and some calibration and fine tuning that kind of takes a weekend. And then we work with them. Then our AI team gets involved and we work with them on prioritizing what their data strategy is. And once we know what their priorities are, then it's all automated. We automate the robotics and that they have a lot of sensors built into it where we can understand the current state of those machines. We are getting software-based alerts and diagnostics that we can act on remotely. And then we have a team of people that monitor these systems 24/7. Now they're not looking at a system 24/7 with their eyes on it. They look at a system periodically, but then they look at a system when there's a software-based alerts that's saying, hey, something's going on with this particular AI vision system, or something is going on with this particular line, or something's going on with this particular robotics. Then they'll zoom in on that robotics or zoom in on that line and troubleshoot it remotely. And that way it allows us to guarantee performance. So we monitor track performance continuously. Our customers can log into the data portal and they can see the performance of that robot almost real time. Anytime performance dips, we work with them to troubleshoot and bring it back up. And so we maintain a minimum level of performance, which is a long way of saying, like, there are trust and there are familiarity issues that we have to overcome in installing and recycling facilities. And we really use technology to do that.
What kind of uptime do you have with the robotics portion?
The average uptime is probably 99.9%. Uh,
Nice. So that's not a concern, really.
So we buy robotic hardware, generic industrial robotic hardware from a lot of companies like Fanuc and Yamaha, ABB, and Omron. These are companies that have been around for decades developing industrial robotics. They make really robust products. We buy those from those companies and we program them and we outfit them with sensors and outfit them with end of arm tools that work for the recycling vertical. So basically, we're converting generic products into something that works for the recycling world.
Very cool. In the facilities that you have installations, what do the recycling rates look like?
Yeah, good questions. Our systems, based on the studies that we've done, we've improved recovery rate 30% for some of these plants. Now, it all depends on how much the plants want to invest in robotics and AI, right? So what we typically do is we recommend starting at the last chance line, or the residue line that they call it. Just imagine a stream of material comes in, it goes in different conveyors, does various things, and then the waste product of that combines into what's called the last chance line, and that's going to a landfill, typically. There's a lot of good material in there because of these sorting inefficiencies. And we say, hey, that's where you're going to get the biggest bang for your buck, because you're losing material that's going to landfill, you're paying landfill costs, and you could be selling those materials. So the ROI there is not just saving on labor, but really additional recovery and additional revenue, right? Kind of almost a no-brainer. So we can start with a vision system. We put a vision system on these lines and we'll tell you how much you're losing on a daily basis. And it's typically in the tens of thousands of dollars on a daily basis. Like, we've done a study and we published this. I got to remember the exact numbers, but you can, if you take a material recovery facility and look at the tons per day that they process, you can pretty accurately convert that into how much value they're losing on an annual basis. It's a pretty good correlation. We've done a study across the country, across different sizes of MRFs and different designs of MRFs. And it's fairly consistent. Like, the correlation, the R square is like zero point 0.9 on the size of the amount of material that they process and how much they're losing. And the math somehow works. Like, let's say, for example, an average MRF that we go into is, let's say, doing 400 tons per day. So they're receiving 400 tons of material and they're processing 400 tons of material through their lines a day. That MRF, you can multiply that 400 by 2,000, and that's how much they're losing per year. So that MRF will be losing $800,000 of recyclable materials per year. By putting 3-4 robots at their last chance line, they can recover at least half of that. You can do the math. The payback on that is pretty much instant, right? So that's where we start, because the economic value is so great. And typically they don't have sorters there anyway. So they don't have to deal with this perception of, hey, I'm replacing a person or whatever. And then from there, we kind of move up. Move up into what they call quality control lines. So these are lines where it's gone through an optical sorter, it's gone through an eddy current separator, or it's gone through some kind of a screen that separates cardboards, and you remove contaminants from there, right? The other aspect you mentioned is quality, purity of what they're baling, right? So in those lines, you can't really sell a product unless you're at least, kind of 90% pure for that product because, otherwise you're not going to get a very good price for that bale. If the bale is a very mixed quality bale, you're going to get a very low price. You might have to just give it away. So you want that purity to be 90, oftentimes 95%. After these different sortation technologies, the purity could be somewhere between 70 to 85%, and you still need to remove that additional 10, 15% of material. We put robotics there to be able to remove that and fine tune what goes into a baler. If you do all of that, you can see that a plant can easily justify 6 to 10 robotics for a medium sized plant just in those types of operations.
But what does your blue sky look like in terms of what would the ideal MRF facility look like, and what would recycling rates be in those facilities? I mean, and the reason I ask this is we've seen recycling rates in North America hover at in the 20%, maybe even sub like sometimes 10-ish, 15% rates in some states. How do we get that up? It would be my follow up question is how do we get that into the 70s, 80% ranges where we need it to be?
Yeah. Yeah, good question. So let's break that number down a little bit so that when you say
Mhm,
20%, what that refers to is the recycling rate from household to the
mhm.
end, right? So from beginning to end. So that 20% of material is what's going into material recovery facilities. And another 30, 40% of that material is being lost in material recovery facilities. So in material recovery facilities, through AI and robotics, we can bring that up so we can capture most of that 20% that's being sent to recycling to the collection facilities. To get that 20% up, it's really around regulations, right? And we're starting to see some of that in the US, what is labeled as extended producer responsibility policies, EPR, where this is shown to have very, very successful outcomes in Europe and Canada, where recycling rates go up as you implement these policies because it gives wider access to recycling programs and also stricter floor on what is recycled and how much of that should be recovered. So these regulations will increase that 20%. Oftentimes, when before APR programs started, to after these programs, recycling rates have doubled, tripled in a lot of places. These are very effective policy, and where we have to where that affects us, and material recovery facilities is if you're increasing the volume of material that are coming into these, now you got to be even more prepared to deal with that volume, to deal with those sorting and processing losses, right? So I think that's probably the fastest way that we can increase recycling rates in the US is to be able to rely on policy and then implement technology that can deal with those policies.
How do you feel robotics and AI can help companies to be able to comply with these policies that are already in place in a certain number of states? We had Risa Dimino in one of our previous podcasts talking about EPR and how EPR is present in a number of states and coming in several others. Does robotics and AI play a role at all in helping MRFs and other recycling facilities to comply with EPR, et cetera?
Yeah, absolutely. I mean, EPR is a huge tailwind to our business. So whether people know it or not today, I believe that AI is going to be key to implementing a good EPR program. And I'll explain that in a little bit. But just to touch on what EPR is, EPR is really turning the funding model upside down in terms of how recycling programs are funded. Instead of it being funded by cities and municipal governments, recycling programs are offset by basically what people pay into these programs. The, the, the financial and operational responsibility of running recycling programs are shifted to producers. And the fee is based on how much the burden of that producer is in terms of contributing to the problem, right? So that's EPR programs, and about 5 or 6 states in the US have passed EPR laws. It hasn't completely implemented yet. They're in the process of planning, and something like 9 or 10 states have it in the ballot for this year. So it's one of those things that are gaining momentum. And I think in the US, you will start seeing these programs being implemented fully in 2025. Now, the first thing is how AI will help run these programs is really around measuring recycling rates and being able to inform these policies, right? All of these EPR policies have minimum recycling rate clauses built in where you have to meet a certain recycling rate. And those recycling rates over time increase for different types of materials. So it's kind of moving the floor up so that recycling rates go up over time. Now, the first thing is you need to, and the other part of it is how much companies pay into these programs depend on how much of their packaging end up in recycling facilities and how recyclable their packaging is. Somebody needs to measure all that to be able to accurately assess how that program is doing and accurately charge the producers for their portion of the fees. And today it's kind of being done by guesswork. It's kind of being done by sort of looking at how much companies are putting into those states, but not really being done by accurately looking at what's ending up in recycled facilities and what's actually being recycled. That data doesn't exist. So it's kind of almost kind of a guesswork. You really need AI systems, vision systems, spectral scanners, maybe even X-ray based type detection, feeding AI models that can give you a granular view of that to be able to inform how that policy is doing and how to sort of charge producers. That's the first thing. The second is because these EPR laws have sort of increasing floor on the minimum recycling rate and recovery rate for these materials, you need infrastructure to be able to deal with that at the recycling plants. And robotics are a very easy way to, on an existing infrastructure, because in the US, there's about 1,000 material recovery facilities. There's about 400 to 500, sort of larger ones. And then there's lots of small municipal owned ones that there's about 900 to 1,000 of these facilities in the US. We're not going to go build new infrastructure to be able to deal with these programs. You have to make the existing infrastructure better. So, robotics is a relatively low cost, very low capital expenditure type of a way to sort of be able to raise the floor, right? If the recovery rate for PET is going from in a plant going from 60% to 75%, well, let's add a few robots at the end of a PET line to be able to recover that. Those are the two primary ways that AI and robotics will help these policies along.
Very cool. So essentially, transparency, right, to deal with EPR regulations, getting enough data to know whether you are complying with it, and then helping you to push up those recycling rates to be able to comply with it is a two-part solution around robotics, AI, and where the industry is going and where possibly we will see it end up over the next few years.
I think it's come a long way. The technology has, and there's a lot of improvements that we're making and capabilities that we're adding to make this whole automation and data aspect of our technology better and better. So things should be getting better from here on out.
Yeah. Well, I guess we have to find a way to move the needle.
Yes. Thanks for having me. I really appreciate
Yeah.
it.
Apurba, the last question is, where can our audience find you if they do want some more data or if they're interested in some of these robotic systems?
Yeah, the easiest place is our website. So it's EverestLabs.ai. And there you can find lots of videos, case studies, as well as ways to contact me or other folks at Everest Labs if you're interested.
Perfect. Lovely speaking with you, and we'll hope to see you soon again.
Thanks, Al Kareem.
Take care, Apurba.